Hi guys, so welcome back. We're going to continue this video for lab number 1. This is going to be for 10 points. We're going to go over what's in your lab drawers and all of the names of the equipment and kind of how we use it. So we're going to get into that, and at the end of the video I'm going to go through everything again. This is going to be an ed puzzle, so you will then be able to identify this stuff, and that's where the grade is going to come from. So here we go. So as we get into your lab drawer, you're going to see all of this equipment. And as we take this out, we're going to start to identify it. So I'm going to, next clip, it's going to be all laid out on the table. So through the magic of video, here it is. What you should have gotten was a lab test tube rack. So this is the test tube rack that holds 6 of these test tubes. We would have 3 Erlenmeyer flasks. This is a 250 milliliter, 125 milliliter, 125 milliliter. So these would be in your lab drawer as well. You would have a wash bottle or water bottle. We would only put distilled water in this. The distilled water that goes in this comes from the carboy. The carboy is filled with distilled water that comes from our little micro still. And so if we come back over here, sorry about that. Then we have a set of beakers. When we look at these beakers, we'll notice, yes, this says 100 milliliters. That's its maximum volume. It doesn't actually go up to 100. The 250, the 400s. If we look at these, the 400 milliliter beaker, its graduations go up to 350. Actually 325, so the very maximum would be 400. So if I say get a 400 ml beaker, you're looking at this, not over here at the graduations. This is not exactly for measuring out exact volumes anyway. Then we've got, for stirring, a glass stirring rod. For transfer and also stirring, we have a micro spatula. And then we have a pipette. And then we have a funnel. This is what is going to be in your lab drawer. The cabinet itself, in here, we would have these items. This is an evaporating dish. We can heat stuff up, evaporate things in that. We can kind of help crystallize stuff. We have graduated cylinders. We have a 100 milliliter graduated cylinder, a 50 milliliter graduated cylinder, and a 100 milliliter graduated cylinder. These are used for measuring volumes of liquids. We would also have, this is for lighting a Bunsen burner. Notice it may not, well this one does. It doesn't have to have the flame. All it has to do is create the spark. And so if it creates a spark, the fuel itself, which is going to be propane, will come through the Bunsen burner. So there's your Bunsen burner. It'll have the gas tubing with it to connect. This is a larger 500 milliliter Erlenmeyer flask. It will also be in the cabinet. Here we have crucible tongs. If we have to pick up something hot with this, we can. Notice it does not have plastic on it, so we can actually put these in the flame. Here we have beaker tongs. These are plastic to get a better grip on beakers. We wouldn't grab 2 beakers at the same time. So we would do that. Notice we wouldn't grab something that is hot enough to actually melt the plastic or rubber coating. And then we have a spot plate. So this spot plate, we can actually put different materials in there and see them react. So this all comes out of the cabinet. Also, at every table we have a test tube holder. Now notice, this is a test tube holder. This is a test tube rack. The test tube holder is used to hold the test tubes. Notice how we hold this underneath. We don't hold it this way because if we were to do something, it would and grab it this way, it would fall. One other little item that is going to be in the cabinet is a grease pencil. Okay, this is used to actually write on the glass, and so this we can remove this. Do not write on the actual white part. It doesn't come off very well. As we move over here to this cabinet, we will notice that if we need specialized glassware, we can have long stem funnels. This is for using filter paper and getting it to filter faster. Here we have a vacuum flask. We can actually put a hose on this, create a vacuum, and pull liquids into this for filtering much faster with something called a Buchner funnel. Here we have access to volumetric flasks. These are not Erlenmeyer flasks. These are used to measure to very specific volumes. So we're going to try to get down here, reading the meniscus right there. That would be 100 milliliter. Down on this one is a 25 mil. So to get down there, we would try to read. My camera's not going to allow it. Get it down here. So try to get the meniscus right there at that point. And so that would be 25 milliliter. And so this will allow us to put the filter paper in there, and that longer stem allows the cohesion of the water molecules to pull it down and actually filter faster. And again, this is the vacuum flask. Over here, this is our cabinet that has 3 different items. The electronic stirring plates, our electronic balances, and our hot plates. And then of course down here there are the cords for the hot plates. The electronic balances, once we get them plugged in, we bring this up, we would hit on. We don't want to put anything on there until it wakes up and it is ready to use. So it takes a while. So if you put something on there before it gets to 0.00, it's going to have a problem. Once we put something on there, we don't want to put anything directly onto the actual top or the plate. So whenever we put things on here, we want to measure in the weighing dish. And so to be able to do this appropriately, instead of taking the mass of the weighing dish and writing it down. So once we get this, we can take the weighing dish, put it on here, hit 0, then take the weighing dish off, put the material in it, and then when you put it back, that would be the mass of the weighing dish within 1/100 of a gram. Oh, or not. I think we've got some air coming through here. Coming over here to the electronic stirring plate. If we need to stir some material, we would take this magnetic stirring bar. So here's our magnetic stirring bar. We can put this into our liquid. Let's say there's something in there we need to stir. And then that will turn that on. That's if we don't want to use the glass stirring rod. And so this can help us stir our material a lot more efficiently. Now, once we get this done, if this was a material that we didn't want to touch, but we needed to get the stirring bar out, we have this. This is the lab stirring bar retriever. And so it has another magnet on it where you can just take this out. We would take that, put that in somewhere and rinse that off, and it would be safe that way. Over here, hot plate. So we would be able to adjust this. We do not leave these alone, okay? We don't leave them turned on. We don't leave them unattended, and especially if they have something on there. So next we turn to some of our supporting apparatus. This is the support stand. On the support stand, we can put down or put on it a ring stand, depending on what size we need. And so the ring stand would go on. We would, sorry about this. We can adjust that, and then we can even put on the wire gauze. This does have the ceramic disc for heating, but this is a wire gauze. We could put on here just some other general type of clamps. These general clamps, we can use this to hold just a test tube or something else. And so this is adjustable here. We can do this. We can turn this and then adjust what size or angle we want. if we need to put a test tube in here. Again, this one does not have any rubber or plastic on this. Some of them do. If you are going to heat this, make sure it does not have the rubber or the plastic. All right. And then finally, if we're going to put on a Buret clamp, we have two different types. So I'll put both of these on here. So this, thank you for your patience. So I've got both Buret clamps here, and this is not something you would want to do single-handed, but this is the way this Buret clamp would work. You need to push on this back part. You want to push this forward. All right, and then we would put, that would clamp right in there like that. So that's fairly easy to use. This one, we have to use two hands. So let's see how well we can do this. This is, you would pull this down with one hand, 1 second, and it would look like this. So this is a burette or a Buret. And so this is a measuring instrument as we look at the amount of liquid we would have in here. It would start at 0, and then as we use the material through the stopcock and we disperse that, okay, we're going to make sure that whenever we put this up here, it's going to be off before we fill it with a funnel probably. Moving on, over here we have a mortar and a pestle. If we need to grind up some materials, this is the pestle, this is the mortar. So you got your mortar, this is your pestle, you can grind. If we need to heat up something really, really, really hot, we're going to use a crucible. And of course, this is why we end up with something called the crucible tongs. So we can heat the crucible tongs. We can pick up the crucible if it's like red hot or just hot enough to burn us. And even the lid. These are made in such a way that this is the way you pick those up. All right. They are also made to go inside of, so they are also made that if you need to place these into a ceramic or the triangles, okay, this is a ceramic triangle which holds these crucibles. And so if we can put a Bunsen burner underneath of that, we can actually get this really hot. That would be without oxygen. This is with oxygen. So there we go, folks. We do have a watch glass. So this watch glass, we can put things on there and let just water evaporate. Sometimes this watch glass, we will put it over top of a beaker to keep everything from splattering out or just keep things from splattering into it. And so that's what this watch glass is for. Then we have other volumetric pipettes. And so this is a barrel type pipette, and this one is going to be for about 5 milliliters. It has graduations on it, and we have these pumps. This is, the red will pump 25 milliliters. This will pump, the green will pump 5 milliliters, and this one will pump 2 milliliters. So if we've got a 10 milliliter barrel pipette, we might use the red one. Just make sure you don't go too far and pull the liquid up past and into the pump itself. These are plastic. These are made to be disposable. Some of these are glass though. Some of them are glass, and these are not necessarily quite as durable. They will break. These are volumetric pipettes. And so this is a 10 mil volumetric pipette, and we look at this, we pull straight up to the meniscus right there at that line, and that is going to be 10 milliliters. So if we want it to be a lot more precise and we are measuring out exactly 10 milliliters, instead of using a 10 milliliter graduated cylinder, we may use this. To be able to pull that up, we would use probably that, or we can use one of these bulbs. And so the bulb would be put right on there, and we will show you how to use that as we get to that lab. Okay, so hopefully you guys were paying attention. So at this point, I am going to point to the materials or the equipment, and you guys have to identify them for the points. Good luck. So first up, we're going to look at the vessels that we will see the reactions in. So reaction vessels Tell me what this one is. What are these? What is this one? This one made out of porcelain. What is this thing called? What was this one called? What is this one called? I don't necessarily need the lid, but what is this called? So next up are all of the pieces of equipment we would use to measure with. So what is this piece of equipment? What is this one? What is this called? This one is the pipette. That is for a very specific to that line. These are also other types of pipettes which have a lot of graduations on it. And then finally, this glassware right here, right there. What did I call that one? All right, now we're moving on to the equipment that we use to stabilize or move things or transfer. So what is this wooden piece that holds these little guys? Do not confuse that with this piece of equipment, which is used to stabilize or move one of those. If we need to move some fluids or even powders, what is this called? We want to use this piece of equipment. We're going to use it to move small amounts of liquids. What is this one called? We're going to pick up something hot. What is this called? Special type. These, again, picking up something hot, probably not as hot because we don't want to melt the rubber coating. What is this one called? This is a special type of a piece of equipment. Tell me what that is. What is this? What is this one? Might use it to flip micro pancakes. All right, what was this thing going to be called? And what does this get put on? Remember, I called it the wrong thing earlier. And what is this? And remember this piece of glassware? We either have this version or this one that'll hold this piece of glassware. All right, we're at the final part of this. So what is this used for? What's it called? This piece of equipment, what is it going to do? And it has to use this. What would that be? And to get that back out, what would we use? This apparatus is used to burn propane, to heat things up. So what is this called? And